So if you're not here for web services, you should be upstairs. If you're here for web services, you're in the right place, at least as far as I'm concerned. Okay, so web services is a new software architecture, and that should mean, shoulds in bold, so that means pay attention, that should mean that we need a new security architecture. We shouldn't take the same old security architecture we had for other kinds of applications and roll it out for web services. Quick note on myself, I'm from Arctec Group. We're a boutique, very boutique, consulting provider based in Minnesota. We work all over the globe. Also the leader of the OWASP XML Security Gateway Evaluation Criteria project, which you might find interesting if you're interested in web services. And I have a blog at One Raindrop that you can sort of follow whatever I'm working on. So before we dive into the top 10, I'm sort of the why guy. So why are we writing web services at all? And there's a lot of tremendous amount of FUD and vendor hype around web services. So I'm going to loosely define web services as a set of technologies that deliver three things. They deliver virtualization. So we want Bangalore, Beijing, Boston all to be connected. We want to be able to chop up work and deliver it from where it makes sense. We want interoperability. So we want our .NET stuff to talk to our Java stuff. We want our PeopleSoft stuff to talk to our Siebel stuff. We want our SAP stuff to talk to the web. We want all of these things to talk to each other. And then finally, we want reusability. So we've been in companies where there's acquisitions made, there's consolidation, there's decentralization, there's all these different things going on. And all the different systems have different definitions of users, different definitions of price, different definitions of order. So we'd like to get more centralized claim systems, pricing systems, order management systems, and so on. So those are the three main goals of why we're writing these things in the first place. What do we mean when we say technically? What do we mean when we say a service? Without getting into SOAP versus REST or any of these other kind of technologies that are out there, we're really talking about a service that separates the interface from the implementation, which is something that we learned from object-oriented programming. So we want the interface, get customer, get order, to be separate from the implementation, the business logic code, the data access code that actually fulfills the request. Secondly, there's a separation between the service and the message document. And so the service requester could be implemented again in C# and .NET. The service provider could be implemented in Java. And the unifying integration point is the message document. So it's not a binary integration, it's a message document-based integration. Now when all this stuff came along, the first design principle of SOAP, 6, 7 years ago now, maybe 9 years ago, was that SOAP was a firewall-friendly protocol. The security guys figured out that developers were putting holes through the firewall and accessing back-end data. They didn't like that. They started turning off the ports on the firewall. So of course the developers are pretty smart, so they just took their little ant farm route around the firewall and came up with a protocol that could go right through it, port 80, port 443, which was SOAP. Bruce Schneier's quote at the time was calling SOAP a firewall-friendly protocol. It's like having a skull-friendly bullet, which is a good line, and why he's on the cover of all the magazines. But how helpful is that really? We have learned over the years that people make common recurring mistakes. This isn't the OWASP Top 10, but I'd call this the old school version of the OWASP Top 10. This was James Gosling, Bill Joy, and Peter Deutsch at Sun Microsystems back in the early 90s, talking about the 8 fallacies of distributed computing. So before there was an OWASP Top 10, people were building distributed systems based on Unix and other systems, and they made mistakes, surprisingly. And so these were 8 common mistakes that people make, things that you assume are true when you're building out a distributed system, and then later, usually when it's in production, you find out that these things are not true. You assume the network's reliable, you assume there's no latency, you assume you have infinite bandwidth. For our purposes here today, we care about number 4. We assume the network is secure. And that obviously has turned out not to be true. So when web services came along, we had our firewall-friendly protocol, and that sort of broke the security architecture we used. The security architecture that most people use looks like this. You have a bunch of good stuff called SAP and Siebel and mainframe. You connect it to the web by a three-tier design with a presentation layer, a business logic layer, and a data access layer. And we know the internet's bad, right? We've heard about attacks here for the last day and a half. We know all the different attacks that happen on the internet. We know there's bad stuff out there. So being good security guys, we want to separate our good stuff from the bad stuff. And the tool we've used to do that is Visio. We've used a Visio tool. That stencil, I mean, that's the one I recommend because it has both the wall and the flames. So an attacker tries to get through that, they're gonna run into the brick wall, fall over, and then burn to death. I mean, there's no way you can get through that. It's literally impossible. Problem is it only exists on Visio. And the problem is there's not a clean separation of good stuff and bad stuff. The world actually looks like this. And so that's led to some interesting side effects. So this is a project done by some folks at McAfee. You can go and buy user name and password combinations for various banks. So depending on the balance, you pay about 8% of the total bank balance to buy the username and password credentials. So if you have a Washington Mutual account with $14,400, could buy your username and password for $600. MBNA account with $22,000, I could buy your username and password for $1,500. This is the part I love about this report, though, and the link there is on the bottom. What I love about this report is these guys have a money-back guarantee. So it's like Walmart or Sam's Club. Like, if it doesn't work, well, we'll give you another one. It's like real capitalist economy. E-Trade, they actually will reimburse their customers for identity theft. So 2006, this was a 10Q filing to the SEC, the whole 9 yards. So they paid back $18 million of losses, 10 million of which were identity theft related. My guess is that that would be, they were probably more than that. Those are just the ones they agreed to pay back. Those are starting to be some big numbers. So I would actually blame all of this stuff on the good stuff versus bad stuff, Visio firewall architecture, actually. So how are we going to stop all of this going forward? Well, we all know confidentiality, integrity, and availability, right? That's what we've been trained to do, and that's how we stop all of our attacks. Absolutely not. Worst possible thing you can do is try to design a system using confidentiality, integrity, and availability. Reason why? Information security is an oxymoron for the 21st century. Just like military intelligence and jumbo shrimp, information security assumes that we can reconcile information on the left-hand side of that slide that's inherently messy, fractal-like, and unpredictable with this illusion of a veneer of security over the top. And obviously that can't happen in the real world. So in the real world, in the middle, we have this debate. And really the question is this debate going to be a constructive debate or a destructive debate? And that's really the fundamental question. So confidentiality, integrity, and availability isn't going to work, hasn't worked, and I would assume it will not continue not to work. So I'm actually going to say that we as information security professionals should be learning, and feel free to call me a heretic, I'll step back in case the lightning bolt hits. But I'm going to say it anyway, we should actually be learning from software developers, especially people building services. So when we build security services, we want to build security services that have virtualization, interoperability, and reusability. Just use them for security purposes. So we want authentication services, authorization services, and auditing services, and we want to be able to deliver those in a virtualized way so that we can authenticate you in Beijing, Bangalore, and Boston, and then authorize you in Manhattan, right? That's something that we just need to do. We need to start doing. We want interoperability, so we want open standards like SAML and XACML, WS Security, or other open standards, pick your favorite, so that we can authenticate you and then authorize you on your WebLogic system, on your WebSphere system, on your SAP system, on your Vista system. So we need to be able to have consistent policy enforcement across these platforms. Finally, we want reusability. So there's really 3 ways you could do security. You can build out a centralized system, which means that you have your service requester and service provider in the same exact domain, sort of like the mainframe model. That works great, except people stopped building systems like that about 20 or 30 years ago. You can have a distributed system where you have high assurance service requesters talking to high assurance service providers. and the fields will be green, and everyone will win a prize, but it actually is only a beautiful dream. Then there is sort of the, and I'm partially of Scandinavian descent, so I like the pragmatic, decentralized approach, which says, okay, we can't assume we can get all of our endpoints to be high assurance. We can probably get a medium level of assurance if we work really hard. What we can do then is mediate the communications between medium assurance endpoints with one or more high assurance intermediaries. Sounds ridiculous if you think of things in terms of web application design. And so that brings me to my next heretical point. When you think about web services are not, the programming model is based on message document integration. So the programming model to keep in mind in your head in the security model is not the web application security model, it's email. So think about the life cycle of an email. An email message you send to somebody, before they receive it, it goes through spam filters, antivirus, postfix, send mail, what have you. Doesn't matter if you're using SSL, when you receive the email, it matters about all of the security checks that happened in between the life cycle of that email. So that's the model to keep in your head, that we need various high assurance intermediaries that perform a set of security functions on our web services. And basically we want to do this so that security can be a business enabler. Because we have brakes in a car, we can actually drive fast. I can prove this theory by looking at the 1930s Roadster, which looked great, drove 110 miles an hour, had fantastic handling. Problem is, if something happened, you got into a wet spot on the road or a bad driver, you'd get in a crash and you'd die, which is bad. Now, if we look at the Toyota Camry, I believe the best-selling car today, looks good, good handling, lots and lots of safety features. They compete on safety features. They know exactly what Honda's doing, they know exactly what Volkswagen's doing in safety, and they actually compete on safety. So the 1930s Roadster handled the functional requirements, driving fast, good handling, looks good, all of the functional requirements that you'd get in a use case in business analysis, but what they did not handle was the non-functional requirements. That's the difference between, one of the differences between the automobile industry of the 1930s and where we are today. So lots and lots of safety features in a brand new Toyota Camry. Anti-lock brakes, seat belts, airbags, side curtain airbags, and so on. And oh, by the way, third-party independent verification. So that's sort of why we're here. Let's look at the OWASP Top 10 for web services. We want to apply the work that Andrew Vandersock and the rest of the folks did on the various incarnations of OWASP Top 10, which has obviously been one of the leading awareness tools in the industry. And we want to show what things remain from web application security vulnerabilities and what are the new nuances or new issues that we have in web services. So we have a list of 10 web services vulnerabilities, and then of course guidance on how to protect your web services environments from those. So the draft is now being reviewed. If you're interested in being a reviewer of the draft, just drop me a line and let me know. Email is on the blog, or I'm pretty easy to find in the Google. So far we've gotten some good feedback, especially wanted to note Mark O'Neill and James McGovern. I don't know if James is here, but I think he's here today. So he's doing a lot of things on web services and has been helpful. And our goal is to publish this to the wiki by OWASP Portugal. So we talked about web services. A user clicks a button there in the upper left-hand corner, generates an HTTP request, and then web services literally could be anywhere else in the architecture. So there's many, many cases where you might use web services talking to an ESB, talking to a backend system, putting a SOAP interface or a REST interface in front of something like a mainframe or Siebel or PeopleSoft to make it easier to talk to. And the question is, how are we going to find and fix all the security vulnerabilities that can fall out of this? So let's look at some vulnerabilities. So the first one, I should note, of the 10, we basically have 8 vulnerabilities from OWASP Top 10 that are more or less the same. They just have web services nuances, and then we have 2 new ones. So I'll get to the 2 new ones last. Of course, injection flaws. This is an OWASP conference, so I'm not going to spend a ton of time on how SQL injection works. But I wanted to note one thing, and that is, in web services, we have many, many new targets for injection attacks. Web services are typically, especially SOAP web services and WS star web services, such as you might see in Vista, WCF, are composed of lots of parsers, lots of moving parts, registries, configuration files, schemas, and so on. So there are many new targets for injection attacks. And the basic principle remains the same from SQL injection in web applications. Service requester and service provider are decoupled. So just like your web server doesn't control the input that the browser sends, the service provider has no control over what the service requester is going to send in. So the service requester could send valid data, or they could send the famous 1 or 1 equals 1. Depending on how the query is implemented, the query on the back end appends the data and then returns all of the rows in the database. Issue number 2, malicious file execution. This actually was one in the OWASP Top 10 that actually has web services examples already into it. So this one was more or less talking about the same thing. Again, the issue that we have here in web services is that from a malicious file execution standpoint, we have many new targets for people to target, but the fundamental principle remains the same. So the ability to send XML documents to the service, this is an example from the SIFT web services paper teaching old dog new tricks. And effectively, the service requester sends malicious code in the form of XML. And the first thing the service provider is going to do is parse or scan that information, and we can then send back the scanned information neatly packaged in XML back to the service provider. So this actually uncovers one of the main issues with web services security. We assume that mostly everything coming in and out is XML based, which means the very first thing we need to do from an implementation standpoint is parse that XML. So your parser, which was designed to be pretty low level down in the stack, is close to the data. The parser is now actually on the front lines. So we've sort of flipped the architecture where we would usually have web server, business logic, data access. And we've taken the parsing and put it on the very front lines where it was arguably never designed to see. So there aren't a ton of real world concrete examples of widespread attacks against XML parsers, but I think that's a fertile ground that we'll see a lot of things coming up in the next couple of years as more systems rely on XML and as more attackers realize what attack surface is there. Insecure direct object reference. Again, this is fairly similar conceptually. So developer exposes a reference to an internal implementation by mistake, allows the attacker basically to bypass the authorization scheme and manipulate it directly. The big problem we have to deal with here in web services, again, comes back to complexity and moving parts. So an example here, let's say I write a SOAP message, a SOAP service to buy some stock. Then I say, okay, I'm not going to have anonymous access because people are buying stock. I'm not just going to let anybody buy stock. So I'm going to actually put a WS security header on this message, ask for a digital signature, so I get integrity, I get authentication, and life is good. So I get a SOAP message into my service provider, it's signed, I can verify the signature, I can verify the message for integrity, life is pretty good. The problem is that a number of IDEs or just poor programming practice will automatically generate not just a SOAP interface, but also a REST interface. And you may leave, and we've seen this in the field a bunch of times, where a REST service gets published alongside the SOAP service, and so that an attacker can execute the HTTP GET call on the bottom with a number and then take the and then make the request to buy the stock directly. So the rule of thumb here would be, if you're publishing a SOAP interface, turn off REST. If you're publishing a REST interface, turn off SOAP, and so on. So number 4, information leakage and handling. Applications can unintentionally leak information. Again, we're back to the sheer moving parts WSDL, XSD, XML that we have to deal with in web services. They all have potential to leak information either directly or indirectly about the configuration. So a number of vulnerabilities. In a SOAP-based web service, WSDL is often published on the network and describes the operations of services. And again, we have the automatic generation of WSDL by IDEs. XSD is often available to attackers, and XML to allow the data types and values so the attacker can craft a much more targeted attack with the payload. And then the UDDI, or the registry that you're using, can leak more information about metadata and policy information that actually govern either the structure or the behavior control of the system. Number 5, broken authentication and weak tokens. So we have flaws like failure to protect credentials and tokens, token lifetime, claims and assertions throughout their life cycle. So Microsoft, IBM, the other big players in the web services industry have moved us from our happy little role-based access control world and have set us down, at least from a web services standpoint, in what they call a claims-based access control, or CBAC. And so where a role-based access control world relies on knowing everything about a subject, an object, and a session, mapping that together in some sort of policy, we have no such knowledge across the subjects and objects and sessions. We actually have a set of claims. Those claims or assertions then need to be validated and evaluated. And so they're evaluated based on a lot of factors, but the point is that we don't have a static mapping between subject, objects, sessions, and roles. We actually have a composable set of specifications that we need to evaluate the inbound claim that we receive and make a security decision. Much more analogous to how ATM security would work or credit card security would work. So you could imagine getting a FICO score, just like when you go in to get a loan. The first thing the bank is going to do is run your FICO score. If you have 700, they'll probably give you a loan. If you're below 700, they probably won't give you a loan. Even if you're above 700 as a score from FICO, they may only give you a loan up to a certain type. So it's a very composable way of making security decisions in a quick way, and it relies on a confidence score. So, or you could summarize what I just said for the last 2.5 minutes as Keith Brown said: you can't authenticate the client, so don't even try, which is a more succinct way of saying what I just said. So if we can't authenticate the client, we're actually going to put a token in the message. That's a standard way to do that is a WS security token, which turns out to be a good thing because we can get a WS security token from Active Directory with Kerberos tickets. We can use X509 digital signatures. We can use SAML assertions, or we can use username and passwords. So 4 different token types we can use. Unfortunately, we can be WS security compliant, and all of those tokens that I just listed off, Kerberos, X509, SAML, and username and password, have wildly varying security properties, as you might imagine, right? And so we can be WS security compliant. WS security was designed as a checkbox for security, and like all checkboxes, it's useful for some things and not for others. One of the things it's not useful for is, again, it equates username and password, unsigned token, with other tokens such as SAML, X509, and Kerberos. So I could have a SOAP message. An auditor comes in and says, hey, you can't just send a SOAP message with no security tokens in it. You need to do WS security. Go back to my desk, implement WS security. What's the easiest way to implement WS security? Username and password token. So I've implemented WS security. I've added my password into the SOAP message that goes over the wire, and I've implemented it with password text that's visible. So now I have a web service that's arguably less secure than it was when I had no WS security, because I've actually broadcast my password in clear text on the network and to everyone who receives the message. I can make that stronger in WS security by adding the hash password digest. So my username is in the clear, which is fine, but my password is now hashed. So I've fixed that one weakness around having a clear text password. So the token is definitely stronger than the username password in clear text token. But the problem is that the message is not hashed, so I don't have integrity. There's no timestamp, and there's no nonce. So I would want the nonce and the timestamp to help deal with replay attacks, because my service is just sitting there listening passively, and I don't want to buy 100 shares of Amazon stock. I wanted to buy 10, and somebody resubmits it 10 times, and now I own 100 shares of Amazon stock. So this token would then still be vulnerable to replay attack and various other timing attacks, because it lacks a timestamp and it lacks a nonce. So a lot of these decisions around implementing the authentication schemes, the token schemes, and the claims-based access control are left 100% up to you. So you're using WS Security, that's great, but really what Microsoft and IBM and the other vendors did is ship you a box of Legos, and you have to figure out how the Legos are going to all fit together. Another variation of this that I've seen quite a bit of is that people then really drill down on WS Security, apply WS Security, and they apply it on one side of the equation. They apply it maybe on the request side and forget about security on the response side. So the service requester sends in their WS Security message to the service provider authenticates that request, sends back the response, and there's no security tokens in the response. So the service requester just gets back the data inflow, but has no idea where it came from. It's not signed, no authentication, no integrity, don't know where I got it from. If you think about it, a lot of times this real sensitive data is coming back in the response, not in the request. Insecure cryptographic usage, number 6. So as I alluded to, we have a box of Legos provided to us by Microsoft, IBM, the other standards vendors, but we don't have clear guidance on exactly how to use them. And there's a really nice treatment of exactly this subject in a paper that Brad Hill wrote from ISEC Partners, and I'd encourage you to Google around for that one. I don't have the link on the slide here, but Brad Hill's paper was at, I believe, at Black Hat last year, and talks exactly about this issue. So the issue is misuse, misadaptation of web services security mechanisms. That's the new web services vulnerability that we're talking about here in number 6. Of course, all of the same issues that we've had with people inventing their own algorithms, inventing their own schemes, and their own new ROT 13 still apply. All the same things we had in OWASP Top 10 issue of this all still apply, but we have some new ones. The best example, the main example we've seen in the wild was various vendors in the early days started to implement WS Security with digital signature. And so they implemented the service provider that said, I'm going to get in a SOAP message. I know that SOAP by default has no authentication, no integrity, so I'm going to make sure that all these messages are signed, or I'm not going to accept them. So the service providers started checking to see if the message was signed. So that was a good start. Problem was, these same service providers forgot to check if they trusted who signed it. So they just checked for presence of a signature and didn't check if they trusted who signed it. So again, these are all things that are left up to implementers. So standards get us part of the way down the field, but definitely nowhere near all the way. And we'll see actually an example of this that happened about 3 weeks ago at Google of a similar issue here. Just building a little suspense for number 10. So, number 7, insecure communications. As much as I like to make fun of SSL because people think it's a complete solution, not having SSL turns out to be a bad thing, even for web services, for many of the same reasons, and one new one. SAML and WS security tokens are, of course, vulnerable. Any of the security tokens we use are vulnerable to timing attacks, replay attacks, and so on. So we want to have SSL in place to minimize the ability of the attacker to sniff the traffic and get the token. So our SAML assertion looks like this truncated SAML assertion, has session index, has authentication indexes, all the things that you would use on the back end to look up the SAML assertion in and make sure it's valid. If you pass it over HTTP, it's all sent in the clear and can be replayed. And if you pass it over SSL, of course, you've minimized the attacker's ability to do that. So here we're talking about passing the secret key around and letting people have access to it if we're using insecure communications, such as HTTP. Okay, failure to restrict access. Sometimes the only protection for a service is that the method calls are not presented to unauthorized users. So probably the best example I know of this, at least in enterprise computing, is MQ series. So MQ series has authorization with no authentication in many cases, how it's implemented, which I've never quite figured out how that worked. But basically, if you know where the MQ is listening, you can put a message on it. And that MQ then connects you to the mainframe, and usually the thing that runs your entire book of business. This is also relevant, of course, because again, we're using web services in the first place to provide interoperability. We have a bunch of legacy stuff on the back end that actually runs the business. It's why we get our paycheck every 2 weeks. But it's hard to talk to. Not everybody wants to have an MQ listener running on every single web server. So you put a web service in between it, make it easier to talk to. So the web service, in fact, then is a gateway. It also can be thought of as a gateway vulnerability. So just like we have gateway drugs, where you start smoking marijuana and you wind up on heroin, you may put a web service in front of your mainframe, and then by the end of it, if it gets exploited, your sysadmin is smoking marijuana, so or worse. So the issue here again, we have tools that are automatically generating things, and we have a very, very large attack surface and configuration for people to traverse through to have any assurance in all these things. Okay, so now that sort of completes the 8 that are we're reusing from OWASP Top 10. Our 2 new ones, the first one is broken XML. So as you might have guessed, since we have a message document paradigm for our integration, there's lots of attack surface, lots of vulnerabilities in this case. So we're not using a binary integration like EJB client talking to the EJB server. The integration is based on message document such as XML. So there's 2 main ways we can see vulnerabilities coming through. We can see structural vulnerabilities through types, and then behavior through bad parsing or bad validation. So in this case, there's really sort of a decision tree that you can work through to find vulnerabilities in broken XML. But first is not validating against a schema at all, which I would say at least half the time, if not more, is the case. So no validation whatsoever. So you're taking in untyped data and then making business decisions on it. The second thing that you may do is maybe using the wrong schema, such as a DTD, which actually can directly lead to XDOS. Microsoft and IBM and other vendors have been good about pushing people away from using DTDs, and it's not allowed in the current spec. Needless to say, lots of people still use DTDs instead of XSD. Every DTD parser that I have seen is vulnerable to XDOS, XML denial service attacks, through recursion and other things. And then finally, we could be using we could be schema validating. We could be using XSD instead of DTD, so we could be doing both of those things correctly. But if we validate against a weak schema or a lax schema, we really haven't solved our problem. So we really need a hardened schema, ideally, that would set things like maximum lengths, that limit the character sets, enforce types and encoding, and so on. So it's really a 3-part rule when we look at the vulnerabilities of XML, which is, are we doing schema validation at all? Are we doing it against the correct schema? And then have we actually hardened the schema? So those are the decision tree, and we'll go through a number of examples in the Top 10 Web Services document for you to look through on those. And then the last issue, identity misuse, number 10. So identity is the basis of the claims and assertions in web services. And then the identity is consumed to make 3 important decisions. Routing decisions. Where am I going to route this message across the ESB, across all of my different parts of my system, across MQ series, get back to SAP, get back to PeopleSoft, what have you. Make business logic decisions based on identity. So sometimes it's funny, I was in a meeting not too long ago with a client, and he was an application architect. I was helping with security architecture, and he said, why do the security people even care about identity? It's actually an application issue. And if you think about it, he's actually partially correct, because identity is where the subjective meets the objective, and basically every single application decision is going to be based on an identity. Of course, the part that we would like to care about as security people is that we've protected that identity, so the quality of the decision that's made when the subjective meets the objective is a good one from a policy standpoint. And the last part, of course, everybody thinks about identity as an access control mechanism, and it certainly is that as well. So the problem that we're talking about here in identity misuse is these are three very different types of decisions. A routing decision, a business logic decision, and an access control decision are three very different decisions. Ideally, these can and should be vouched for by different authorities, but unfortunately, web services, just like web applications, combine all of these into one magic security token that we use for all of them. So all your identity belong to us. So that sort of leads me to what I think is actually the biggest security hole in web applications and web services. And that's this, the username and password login screen. So we spent, I don't know, 15 years now building web applications and telling people to put their username and password into a web browser, and then we make fun of them and say the users are stupid when they get phished. So this is the same thing that we put on web applications in 1995. It hasn't changed. So who's the stupid one? The user or the people who keep building access control mechanisms that look like this? We report, you decide. So unfortunately, as hopefully you've picked up by now, taking that next step to WS security and SAML and moving away from this is also fraught with challenges. And our friends at Google just had their own challenge. This was about 2 weeks ago, I think, 2 weeks ago today, where they decided that SAML was pretty good, but they could actually make it a little bit better by taking a few of the things out of there that were annoying. So the thing that they took out was the relationship between the identity provider and the service provider. In SAML 2.0, that's a scoped relationship. I go to Google Mail to access my mail. As a service provider, Google Mail sends me back to the Google Mail identity provider. I get a SAML assertion back that says Gunnar can access his Gmail, and this identity provider has given this assertion that's scoped between the identity provider and the service provider. The part they took out was they sent me back to the identity provider. I logged in, and then that token was valid for any Google service. And so you can read all about this. CERT has issued a statement on it, and I'd encourage you to read the identity blog link here from Kim Cameron that goes into a lot of the issues that came out of this. And so the problem is effectively this. The service provider is sending me back to the identity provider, and ideally I should come back with a red token that says, this red token allows you to access this red service. Problem was, we have what I'd call the dreaded purple token, and that's where the red security domain and the blue security domain get mixed, and the token becomes purple. I go to the service provider, they send me back to the identity provider. The identity provider says, here, have this purple token. You can now access the red domain, the blue domain, the white domain, what have you. So it's really mixing all of those decisions together is what led to a unilateral, unscoped SAML assertion available on Google. So there's lots of ways that you can misuse things that are improving upon the standard username and password that we use, but also bending them to your will. You have to be extremely careful. So that's the OWASP Top 10 web services. Again, would encourage everybody who wants to do any review work, just drop me a mail, and then we'll be looking to publish this by OWASP Portugal here in about a little bit more than a month. And again, our goal here is to build security in. I said that information security, we can't really reconcile information and security because innovation is inherently messy and fractal-like. Security is really boring and homogeneous. So it's hard to actually unify these things, but it actually has been done at least once before that I know of. and it was done by a guy named Joseph Strauss. He was a structural engineer. He had a security safety innovation called hard hats and safety nets on bridges. So hard hats protect the bridge workers' heads. Safety nets, people who fall off the bridge would fall into a net instead of fall into the ocean and die. So that's a safety innovation. Very first time he ever used his safety innovation, he actually saved the lives, his innovation saved the lives of 19 bridge workers. So that's a pretty darn good track record on your first time out. So he handled the safety part, and the result was actually quite beautiful. The Golden Gate Bridge was the first time that hard hats and safety nets were used in bridge construction. So thanks everybody for your time, and enjoy the rest of your conference. Oh, I do have time for questions, actually. Did you have one?
Yes.
Oh, okay. More than one, okay.
So you have those two items at the end because it's sort of, I feel like the most priority long at the end?
I don't think the priority is baked. In fact, you could probably make the case that XML should be number one. Yes, prioritization, absolutely. Yep. How much of an issue do you think that is for people who are reading this? How much do you think they like just get to 5 and say, okay, I can't deal anymore, or? Okay. Okay. Yeah. Okay. So we want to go in with our best punch. Okay. Any other questions? Yeah. So I started with the OWASP Top 10. So the goal here is awareness, and obviously there's a lot of awareness about OWASP Top 10. So, and I think the general security principles in 80% of the cases of the web applications apply directly or indirectly to web services. So I wanted to basically build upon, okay, if I know what input validation looks like in a web app, here's what it looks like in web services. I know what broken authentication means in a web app, session cookies or what have you, here's what it looks like in web services. So the two that are not there are basically around cross-site scripting and CSRF, which you could also look at web services as a vector of that, but I think the two issues that we added in, broken XML and misuse of identity, are particularly important in web services, so that's where that came in. And again, this is draft, so people can feel free to throw their own hat into the ring on this stuff. I think there actually are some tools that can do some of this. In the document, we actually highlighted where we think either automated approaches like static analysis or other tools could help solve some of these issues or find them, and where manual approaches are more useful. So we definitely want to highlight things that we think can resolve them. And again, the idea is to actually make it easier to build secure softwares. We're not just harping on vulnerabilities for vulnerability's sake. So that was on the list, and what we talked about it was in the context of broken XML. So if you want to read through the section and see if you think it deserves, first-class citizenship or what have you, that's definitely a fair point. Exactly. So I think one of the things that is an issue based on that is that we have a hard separation between authentication and authorization, depending on how you look at it, and it makes it easier potentially for input validation to bypass some of the authorization schemes. So some of the things that actually Jeremiah Grossman talked about in his first talk yesterday, web services is a perfect candidate for all of those things. Yeah, that is a good question. So I mean, I think part of it comes down to is what's the transaction that you're running. The other thing is, again, the access control model is a claims-based access control model. So you'd want to treat those claims differently depending on where they came from and who vouched for them and how well protected they were when they were transiting. So I don't have like a little checkbox answer on that one, unfortunately. But maybe that'll be the number 11. But I don't think so. Any other questions? Okay, thanks everybody for your time.